is going to be focused primarily on kind of oceanographic and the like, physical habitat, physical processes, and benthic habitat. And so what we did in developing this workshop and the paper that will follow many months to come is identify section leads, who in turn identified authors, co-authors, panelists, presenters. And so what I'd like to do is really turn this piece over to Brian Hooker from BOEM, who is the section lead for benthic habitat modification and then the physical properties and habitat modification. And we're going to start with benthic with Brian as the moderator, 3 panelists. Brian, I think each panelist has about 9 minutes, so I'll just kind of keep timing accordingly if that's about right. So Brian, I'll turn it over to you.
Thanks, Pat. Hopefully everyone can now see our opening slide there. I think that was a great opening by Andrew. I think it really does set the scale too, for how we are addressing a lot of these ecosystem effects issues. We do have a lot of information, I think, and looking at that local micro scale, and it's I think where the information gaps are, we'll see as we go through today, is that connectivity and scaling up and getting in that helicopter. So again, my name is Brian Hooker. I'm a biologist with the Office of Renewable Energy Programs at BOEM, and I'll be moderating today's panel and actually the next 2. On this panel, we have Michelle Bachman, who's a fishery analyst with the New England Fishery Management Council, and we also have Drew Carey, the Chief Executive Officer and Scientist of Inspire Environmental. Lastly, Stephen de Graer with the Royal Belgian Institute of Natural Sciences. Each of these 3 individuals have contributed greatly to the information we have on not only the effects of offshore wind in Europe, but in baseline studies in the U.S. as well. So with that, I'd like to turn it over to Michelle and maybe give a little bit of a overview of why do we care about benthic habitat modification.
Sure. Can you hear me?
Yeah.
All right. Yeah, we can just keep it on the first slide for now. So good morning, everybody. I'm gonna, I think, just try and lay out a little bit about how we approach this topic and the ways that we're thinking about this issue and the lenses through which we're going to evaluate sort of the benthic and substrate and sediment effects. It's interesting, I've been thinking about sort of fouling benthic communities for a long time now and didn't necessarily forecast, looking at them through the lens of offshore energy at this point in my career. But one of the things that is really interesting to me about these offshore turbines is that you're essentially creating, habitats all the way from the seabed surface up, into the water column to the water-air interface, and essentially putting these intertidal habitats offshore. So, we have the structures from the turbines, from the scour protection around the turbines, also any protection that's placed along cable routes. So we're introducing all these structures into the system. And then the question is sort of what are the effects of that? And, this is definitely a sort of helicoptering down or in to the details, kind of question, but the reason we're interested, and I think, Dr. Gill touched on this as well, is that these changes, cascade up through the food web and affect carbon flows in the system and the connectivity of different organisms in the system and suitability of habitats. And so those do ultimately affect fishery species, commercial and recreationally targeted species. They affect sort of other, larger megafauna in the system, and all the species in between on which those animals depend. And so that's, we're really, sort of want to understand some of the details at the scale of the turbine and at multiple turbines and a whole wind farm in the region. And then how does that scale up to these species that we really care about from a sort of an economic, social biodiversity standpoint. And so really the way that we kind of categorized these effects, and this relates, to other sections of the report that you're going to hear about later today. But we were interested in thinking about it in the context of sort of bottom sediment modifications and how that affects carbon flow as you have organisms that are colonizing these substrates, and detritus and as food sources, and you're just changing the way that carbon is moving through the system. So that's one lens that we wanted to think about it from that perspective, and we'll talk about that in a second. Next, we were sort of thinking about how placing these islands of structure in the environment changes potentially the connectivity of different organisms, and kind of creates maybe islands, stepping stones for animals to move through the system, and the implications there. And certainly that's going to depend on scale and setup of wind farms. And so there's a lot of questions and a lot that we don't know yet about how that may play out here. And finally, just thinking about the habitat suitability, kind of at the from the perspective of a managed fish species, or they're potentially using these areas for feeding, for shelter, for reproduction, spawning, and how does that change? Does it attract different species? Does it provide greater or lesser values compared to natural habitats? And also thinking about all that in the context of these turbines being placed in areas that don't have a lot of structure at present, or maybe areas that do have more structure, but natural structure. And so there's a lot of questions there, and there's certainly a lot that we can draw from work that's happened in other regions, and even from work here in the Block Island wind farm, but there's a lot that we don't know. So I think with that, we can probably move on to the next slide, and to
yeah, great. Thanks, Michelle.
Sure.
So yeah, so now as Michelle outlined, we have kind of broken up this topic into kind of 3 different areas, with the bottom sediment modification, the connectivity issue, and then habitat suitability. Like what does it matter? And for bottom sediment modification, I think we'll turn first to Stephen de Graer over in Belgium, to talk about some of the European experience. Like what do we know, Stephen, about carbon flow and bottom sediment modification in the Belgian part of the North Sea or elsewhere? Stephen, are you there?
And Stephen, you're on mute. There we go.
Sorry for that. We lost half a minute. My apologies for that, Brian. Okay, what I first wanted to say before going into this bottom modification is that while listening to the presentation we have had so far, what we have seen is that we have seen quite a lot of very nice infographics. Also, this one is a nice one, and it is, in most cases these infographics, they actually zoom into the single wind turbine, and what we always see is a couple of species that go with it. And I think that's probably what we're going to talk about during this panel discussion as well, is probably what we have to do is we have to look at, and we need to have this helicopter approach, and we have to kind of take a distance and have a look at not only what species are around, but what are these species doing? Not only what is happening locally, but what is happening at the wider scale. And that's probably what we have to try to do. And this is exactly where we're going to start talking about effects on ecosystems, where you have on the one hand side the actual effects and how that links to ecosystem functioning, and hence also production that links to fisheries. So that's probably what we have to do, and probably that's where we could use the helicopter approach as well. What I want to say about this thing is that if it is about the organic enrichment, there's a lot of things that are known, but particularly at the local scale. So we know that there is a biofilter, and these piles are grown by and they are colonized by many organisms. It really is like filtering organisms predominantly that are colonizing these piles. So and they filter the water, which means that they actually collect carbon from the water. They do something with that, and they kind of locally enrich the environment. And actually, what they do is then, of course, they kind of enriching the environment, they also offer food to many of these, to the local environment. That attracts predators, so you really kind of establish a very, very specific local food web with all of its typical species. That's what we know. But probably the next question would be then, what is it we don't know? And that's actually taking these blinders off and having this wider view. What we actually do not know that much is how that actually links to the productivity in general, fisheries production, for example, in general. So at the scale that goes much beyond a single turbine, that even goes beyond an offshore wind farm. So we have to really look at, okay, well, what is happening there? You know, you kind of collect this carbon, you kind of locally recycle this carbon. What does that mean at a wider scale? Is there going to be a change in the secondary production? But also the primary production may be important over there because, of course, as you take away carbon, of course, what is taken out of the system cannot be used elsewhere. So we have no idea yet, for example, of what shadow effects of these offshore wind farms may be, what kind of effects that would have on the ecosystem productivity in areas beyond the offshore wind farms. We have no idea about that. And I think that this is probably what we have to focus on in the near future. Thank you.
Thanks, Stephen. Can you define what you mean by local effect? I mean, because I think that's what we're saying that we do know a lot about. What is the local effect when you say local effect that we do have good knowledge on?
Yeah, a local effect, of course, is very much context specific. What I mean here is that I think that we can all accept the fact that there is something that may happen at a very specific location, be it an individual turbine, yeah. And we know that there are effects at wider spatial scale, be it the Northeast Atlantic, as wide as that, and there is anything in between. So local in this specific context is, if it is about the knowledge we collect, we particularly know a lot about the effects around a single wind turbine. We do have some idea about what that means. For some aspects, we already know what that means at the scale of a wind farm, and those wind farms are not that big as the ones that you plan to construct along the US East Coast, of course, but they are like 200, 300 square kilometers. We more or less start having a grip on that as well. But if it comes to going beyond the offshore wind farm, then it becomes very, very difficult to really know what the local effect inside the wind farm means to processes that actually play at this very wide spatial scales.
Thanks again, Stephen. So Drew, I mean, you know, you've worked a lot in Southern New England, and you know, comparing what European studies, what do you see on in Southern New England in regards to bottom sediment modification?
Well, I think there's two things we have to take into consideration. They're sort of illustrated by both the first slide and the second slide. The first slide showed us, again, an infographic of the Block Island wind farm. And the Block Island wind farm, we've got a lot of data now that was collected through the Rodeo project. As you can see, this is a lattice jacket structure, which are relatively common in early development phase, are less likely to be employed at the larger scale projects we're considering at the moment. There may be some, but we're more likely to see monopiles. So there's quite a difference there between those two. You can see there's space underneath the lattice. There's a lot more surface area. So we have to be able to consider the differences in bottom sediment modification between the two. And then in the next slide, where we begin to introduce the concept of connectivity, we know, as we've already said here, that you're essentially introducing intertidal habitat offshore or in deeper water. And so that's intertidal habitat, which is a hard substrate. In most cases, the projects that, for instance, Stephen has studied, and many of the projects in the North Sea are in quite a different ecosystem. In most cases, they're on what we would consider soft sediment, sand or silt. There's a few projects in Northern England. Westernmost Rust is a good, Rough is a good example, where they're actually located in rocky and sort of boulder habitats. So some of the projects proposed in the United States will be located, likely, if they're permitted, they'll be located in the midst of these kinds of bouldery habitats. So now we have hard bottom substrate, natural reefs, if you will, more or less immediately adjacent to these new structures. So the processes that we need to look at will include the soft bottom modification that we saw in the previous example, but also some effects on these other substrates that are nearby. So we have to, again, expand the scale. We still need to understand what those small scale effects are for those kinds of introduction. And then a lot of people have talked, as you see in this diagram here, about a stepping stone effect for these hard substrate species. We've seen a few effects at Block Island that I think are reflected in Europe, where the dominant epifauna is the mussels and the intertidal zone. And they are apparently moving from the lattice jacket structures at Block Island to adjacent reef areas, natural reef areas. They have occurred there in the past. They weren't there prior to the establishment of the wind farm. So there's prospect of adjustments and changes to adjacent natural reefs, both in terms of the benthic component that we're talking about here, but then also those knock-on effects of the predators coming in and grazing on those substrates, moving off to other locations, the larval dispersal from them. So we're needing to examine a wide range of habitats here, some of which are specific to projects, some of which are a bit more general across the region. And so there's, in essence, there's a little bit more unknown than we perhaps were thinking about before. So again, this scale that Stephen just alluded to is particularly important to understand in terms of connectivity. So this second of the 3 points that we're trying to emphasize is the relationship of an introduced benthic habitat to adjacent habitats. And we're going to have to take into account all the possible habitats that might be affected.
Thanks, Drew. And so Stephen, I mean, I think Drew touched on a lot of these aspects. I know one thing that we've discussed previously too is the kind of the carbon fate. We know that as you discussed, there's a lot of carbon that is produced at the local, but then there's also, I think, studies that try to document where did all that carbon go. It obviously all didn't stay within 300 or 200 to 300 meters of the foundation. Can you tell us more about that aspect of the connectivity between a single local scale effect and potentially the connection to the larger ecosystem?
Yeah. Well, again, these studies have been performed, and I think that they have been performed not only in Belgian waters but also elsewhere. And when you have a look at the carbon as kind of the organic matter, and it is collected on the turbines, and then the drop-offs and the organic matter that is deposited around the wind turbines. This has been shown in quite a few places. And what we have seen until a couple of years, so our wind farms are out there since 2008. So we are now 12 years. We now have 12 years of monitoring done. And what we first saw is that this organic matter enrichment, it seemed to be very much local. Right? It seemed to stretch like 10, maybe 50 meter, maybe a bit more, but about 50 meter. And what we now start seeing is that after like 12 years is that we now start seeing anecdotic evidence. We still do not have the scientific evidence for it, but there are there's some sort of anecdotic evidence that we can see organic enrichment that is actually stretching throughout the complete wind farm, which means that we do see organic enrichment effects up to distances like 250 meters away from a wind turbine. And since our wind turbines nowadays are about half kilometer away from each other, so that means that the whole offshore wind farm looks like to be impacted by this organic enrichment. Impacted, okay, you can look at it in many different ways. Impacted does not necessarily mean that this is bad. We just say it changed, and there is a permanent change, and it looks like this permanent change will go at least at the scale of the wind farm. Whether you want to consider it desired or undesired, that's something completely different. You know, in organic enrichment, we're open the possibilities for quite a lot of species that, well, maybe people like a secondary production that will increase locally. So that's all. This could be considered interest and desired. On the other hand side, of course, the natural system will change, and you may look at that from another perspective, thinking or considering it undesired as well. Beyond the scale of a single offshore wind farm, we haven't found any effect so far. So I don't think that like the organic matter, you know, the particulate organic matter probably is going to stay within the wind farm. The organic matter that will be exported from the wind farm will be by means of these mobile larger predators Drew are referring to. We do see fish coming in. They are happily feeding on this very rich environment. They are feeding, and then they are migrating out of the system. Of course, that is also an export of carbon. That's probably where we touch upon fisheries, because there are quite a lot of these larger predators that do have commercial value. And it looks like cod in Belgian waters, we have seen cod being attracted to it, and then they move in, they move out of the system, they happily feed in the system. It looks like they are doing better because of this locally enriched secondary production. And then, of course, this may have its effect on spawning when they move to the spawning grounds in winter time. So that's the level of organic matter export we may want to think of if we think beyond the spatial scale of a single wind farm.
Thanks, Stephen. I think that is a great segue into our next slide, talking about habitat suitability. So it's kind of the what if that you were talking about. You know, is the effect something that we need to know? I think John Hare, excuse me, not John, it was Chris Oliver at the very beginning said it was 3 questions. There's what we know, what we don't know, and what we need to know. I mean, is it important enough to investigate? And so I think one of the things that we often are conflated with, we often look at things like, is there an effect? And we document the effect, we assess the effect, but is it, are you creating a suitable habitat? It's not natural habitat, it is artificial, but you know, it sounds like from some of your experience in Europe, the animals are utilizing this new habitat, and potentially it's good for some species and potentially maybe not so good for other species. To turn it over to Drew, I don't know, do you have any reflections on this?
Sure. So I think, you know, what we've learned, and again, there's really only one case study here in the US, and we're relying, you know, heavily on the work in Europe to get an idea of timing, scale, and consequence. There's several aspects of habitat suitability we definitely have to consider. You know, in our construct of, you know, essential fish habitat, if we move to the, you know, commercially and recreationally important species, then it's not just food source, but spawning habitat, refuge, other aspects of the habitat that can be very important to different life stages of fish. And, you know, those will vary. So it's important, I think, to understand, again, the scale of potential change. And we're now understanding that scale develops over a number of years. Stephen mentioned that the turbines, you know, maybe half a kilometer apart. Our proposed developments are minimum of 1 nautical mile apart. So they will be, you know, a little bit greater distance in between the turbines that will not necessarily have this direct accumulation of habitat associated with one individual turbine. But I think we're beginning to ask the question, what then occurs in this whole nexus of little islands of habitat that have been generated? Do we get, and can we measure, and can we find a more cumulative effect? One assumes that the mobile predators are going to move around. We obviously have data from Europe that Seals, for instance, if you put a tracker on a seal, heads straight for a turbine, does some grazing, moves to a different one. We don't yet have, evidence of seal activity, offshore, but there are a variety of ways that these things could change and could lead to these larger ecosystem effects. So essentially, at least the way I'm thinking of it, is that this first step and the 3 sessions we have this morning are really relating to how does the presence of these turbines and the cables and the construction activity, how does this modify the environment? And then we need to begin to look at how the rest of the ecosystem responds to that modification. So there are a few benthic species, obviously, that are important, commercial and recreational species. By and large, though, they are creating and providing habitat for a large number of other species. And it's, as it gets complicated, as we get into these food web dynamics, as we get into ecosystem scale, things get much more complicated to be able to discern differences between this kind of introduction. I think what we're looking at right now, as difficult and as time consuming as this was a pretty dramatic, visible effect. Some of the elements could be measured pretty directly. Some of the things that we now begin to think about are much more indirect, a little harder to measure, and also, as we'll talk about a little bit later, harder to separate the signal, the diluted signal of a habitat, all the way through the food web to many other levels, when there are many other things happening in the same ecosystem. And so this is where, these working groups and trying to refine what the important questions are, develop techniques and methodologies to really follow that signal are quite important.
Yeah. If I may add to that.
We have about less than 1 minute, Steve. Yeah, but please do.
Yeah, well, in less than 1 minute then. I fully agree with what Drew just said. Well, if you want to restrict what I want to say within half a minute, then actually what I wanted to say is that if it is about what we know a lot. Yeah? If it is about what we do not know, there's much more. The list is really huge. I think what is quite important here is if we start thinking about how are we going to prioritize, is that we think about what really matters. It should be about societal concerns. Where are the societal concerns at scales that go beyond offshore wind farms are? And I think this is about fish production, that this is about access to fishing grounds, but it's also about population dynamics of rare and protected species and so on. And we first have to identify those questions and then have the hypothesized cause effect links and the position of the offshore wind farms in there. And this will help us a lot in trying to see the forest through the trees, if it is about going from the long list of known unknowns to the priority known unknowns. And I think that's a very important step to be taken. And I think that we have the knowledge, we probably have the knowledge that we could already start going for that shortlisting exercise.
Thanks, Stephen, and thanks for keeping it short there. I think you raised some you and Drew both, I think, characterize that really well. I think a lot of what we're finding, a lot of the questions that are in that big to be answered column are not unique to offshore wind energy. I know on the fisheries management side, ecosystem-based fisheries management is still remains a topic that they're grappling with on that side. So it's the food web dynamics issue. Luckily, I think on the fisheries management side, they've been making a lot of progress on that, and that hopefully we can take a lot of those lessons learned. But there's obviously more to dig into this, and I encourage everyone to join our breakout, not to ruin anyone else's breakout session, but I think this one will be a good one later on. But Patrick, I think I'll turn it back over to you for the question and answer portion.
Great. So we have some great questions in Menti. So we're not going to be able to cover all of them, but I want to let you all know that all of these questions we record. They will go to the authors and panelists, and as they move forward with developing their kind of piece of the paper that will be developed, they will be considering and thinking about all these questions. So I think the questions, some are very specific, but they center on a few things. And I think obviously what do we know about the change, and of course at what scale is going to be really important to people. So I wonder if you could speak about what you've seen either in Europe or in Block Island about any sort of species shift, particularly if it's going to affect recreational commercial fishery species of concern. First, let's talk about in the water column. Then I'll ask about, say, clams and scallops. But what do we know about any change in sort of species composition, either very locally or maybe at a broader scale to date?
Stephen, you want to take it first from the European, and then we'll jump to Drew for Block Island?
Yeah, that's fine. So what we have seen is that there's quite a couple of species that are attracted to these offshore wind turbines, particularly if they are having an extensive erosion protection layer. So this in Europe, in Europe and southern North Sea waters, that actually means that you introduce a hard substrate into a soft sediment environment. So you attract species that like to be in that kind of environment. We have done an estimate of pouting. Pouting is some sort of cod. It's a small cod species. We have done an estimate using scientific divers, swimming transects, counting fish, and so on. And we came up with an extrapolation of about 30,000 or 3 tons of a single fish species that we did have before in Belgian waters before the wind farms were around, but not that many. And now we had like 3 tons of that fish around a single wind turbine, which is huge. So pouting in Belgium is not a commercial species, but it is a species that can be fished by anglers. So I think it's very much the same as the black sea bass in the US that may be targeted around the wind farms. In Belgium, but that's of course different from country to country in Europe, and of course it's also going to change as we progress with learning to best deal with offshore wind farms. So far, recreational fisheries is not allowed in Belgian waters. So actually, there's no recreational fisheries taking place. While they are around, I go fishing there simply because of for scientific purposes. Well, whenever you kind of have your hooks out, you do not have to wait. All the hooks are completely filled with these poutings. So they really are attracted. And it's not only pouting; it's also cod that is attracted, be it to a lesser extent, and then some pelagic fish like horse mackerel that has been found in higher densities. So there's really like a lot of fish that have commercial value that are attracted to the wind turbines. But the issue is whether we can harvest from that, and that's dependent from country to country.
Is there anything known about, say, benthic species like mussels or clams, about any species composition shift because of the kind of benthic changes here?
Yeah, well, this may be very shocking to the audience. The clam fisheries is prohibited in Belgium. we do not have we do have some commercial species, but you cannot fish them. They are fished in the Netherlands, but it's really like small species. The larger clams like you have along the US East Coast, we don't have that. So if it is about the effects on clams, we cannot contribute that much from the knowledge we have in Europe. But what you can expect is that because of this organic enrichment, of course, any clam species that will be affected or positively affected by the presence of an increased organic enrichment is probably going to take profit of that environment. But of course, since we do not have these larger species, we cannot say that much from the Belgian knowledge as we have it so far.
Another question related to this, and then I'll get to another question about kind of the choices of substrate, but what is the threshold of change we're looking at, we should be worried about? If it's a 5% change, so what? Is it 25? What is the threshold of change we're thinking about here?
Yeah, I don't know. It's a hard one. I kind of want to toss it to Drew or Michelle even, on this one, because I think, there are no thresholds. And I think that was one of the things that I think we talked about a lot, at the scale level and, the habitat suitability and what is the point where we should care or mitigate the effect to some way to bring it back to status quo. Drew?
I think there's a couple of things that we could introduce in that regard, and maybe if you go back to the very first slide there, Brian, that might help illustrate it a little bit. I think there's two things in relation to that. One is that, and again, the species that are being attracted here are illustrated in this slide here for that first question. And that is that with this organic enrichment process, it is possible, even in the open ocean, to generate sediments that are so enriched that they become anoxic and they create degraded conditions for the benthic infauna. We've seen this in a number of different locations, both in estuaries and offshore. So I think it's pretty clear that if you accumulate so much organic input into a benthic area, that you're really creating an anoxic bottom condition, then that's gone a step too far. Now, I don't believe we've seen that here, but that's a pretty straightforward threshold in most benthic studies. It's the sort of extreme end of things. The other thresholds that you would need to think about is probably the introduction of non-native species. We understand that they're already present in a lot of habitats. And in talking to some of the world's experts on non-invasive species, their consideration is look at the big actors, the ones that perhaps modify habitat, have a more dramatic effect than others. You can get down to the very tiny micro myofaunal level and find new species, but they're not necessarily structuring the habitat. So the potential of altering circumstances such that we see some non-invasives that have some actual measurable negative effects, that may be another potential threshold. Those are the two that occur to me. I don't know, Michelle, if you have another thought about, obviously, if we start seeing really clear signals in the larger ecosystem that we can attribute to this, then it's a value judgment as to whether those ecosystem changes, you could increase the biomass of a particular species and reduce a different species. And it's a little bit of a value judgment as to what that means.
Sure, yeah, just to follow on that, and those are really hard questions that we consider routinely in a fishery management context and don't, I think, have great answers for. But I mean, some of our sense of the magnitude of a change that might be important will probably relate to the status of the species that are being affected, and if we have a stock that is depleted and we're trying to recover, a minor change may, be a bigger deal. So I think these are questions we're probably going to have as a broader community to try and prioritize and figure out what's important.
I'm going to do one more question, and I'm not giving service to the great questions that are coming in being a mentee. I know that a few folks, staff, are getting comments via text, so we're not going to get all this great stuff. I think there's a lot of questions centered around, is there any studies to look at the kind of materials you use for scour protection or for the bottom around some of these structures that would actually be particular materials that would actually benefit certain kinds of species or life stages of the like? So in so much as this is causing an effect, can we use the materials in a way that will actually cause the positive effects we might desire?
Yep. Definitely a Stephen answer.
Yes. The studies are actually ongoing. So what we have seen so far is we have investigated, and this has happened in many places. We had a look at the species composition, the ecosystem that kind of develops on these erosion protection layers in the business as usual type of erosion protection layers. Nowadays, so like the engineered erosion protection layers, not with the idea of promoting biodiversity, but simply, okay, from an engineering perspective, that's the best we can do. What we are now starting to do is to start thinking about indeed how we can modify these erosion protection layers. And the reason why we want to modify them is because we have seen that what is growing on these erosion protection layers is much poorer than you would expect to find in a natural hard substrate. One of the reasons could be, there's a couple of reasons. size of the area, the island effect could be part of the explanation, but another explanation could be that the erosion protection layers are designed to withstand storms and currents in a dynamic manner. So stones may turn around, and of course, as you start hard substrate moving around, and of course, it becomes less evident for this fauna that is really living attached to these rocks to survive. So we're now thinking about how should an erosion protection layer, how could it look like with a stable and non or less dynamic kind of erosion protection layer, and what would that effect be? And if you kind of push it even further, then you can also see a tendency, and that's particularly in the Netherlands, for example. You also see this tendency to move in the direction of add-on structures that would attract an extra type of biodiversity, like reef balls that would be put on top of the erosion protection layer. So all that sort of things are in the tests of what the added value would be for nature inclusive designed erosion protection layers, but also for kind of ecologically designed erosion protection layers. These tests are ongoing at this very moment, and I think that within probably 1 year, well, let's say 2 years, 3 years, we should have a better view about what the added value really is, and particularly whether we can design those erosion protection layers in such way that they come, as rich as you would expect from a natural hard substrate system in that area.
Yeah, thanks, Stephen. I want to plug what you just mentioned too in Denmark with the nature inclusive designs. They have actually developed a whole catalog. So if people want to actually Google nature inclusive designs, you'll see that they've developed a catalog of different things that they think will have that beneficial effect. One thing I did want to point out that maybe people don't know, I think you do have some gravity concrete foundations in Belgian waters. And concrete is some of the cable protection measures as well, and we've seen less epiphaunal growth on, I think, some of those structures than on natural stone, scour protection around foundations. So I just want to maybe highlight that little bit of difference. I think what you were talking about with less growth, I think some of that might have been from those concrete foundations.
So the erosion protection layers I'm talking about are natural stones. Then they are not concrete. You're right that we do have gravity-based foundations, but the erosion protection layer is natural rocks.
Right. Brian, I'm just because of time, I'm going to probably wrap this piece up. This panelists, thank you so much. This was great. It was rich. The questions are terrific and far more than we could answer today. So again, we are going to break out where people are going to have a lot more back and forth on these issues. So I know it's a little bit frustrating in this style or this approach, where we're going to have somewhat limited questions during the plenary parts, but in breakout, everyone's going to have their screen on, everyone can engage fully, and it can be much more engaging. So